Hey guys, what's up? So now we're going to be looking at multiplication and division of algebraic terms, and it is necessary to reinforce the statement that the commutative law holds for the multiplication of real numbers and algebraic terms. Thus, x times y is equal to y times x, which is equal to xy. That is, xy is equal to yx. Okay guys, so it really doesn't matter. If we're multiplying x squared by y squared, it's the same thing as y squared multiplied by x squared. Okay, guys? Okay, so it says hence the order in which we multiply algebraic terms is not important, and it really isn't. Okay, guys? So I can give you another example here. A times B times C is the same thing as C times B times A. Okay, guys? So the order is really not important. Okay, so let's solve these questions here. And great. So in this case, we're going to have what we're going to do first, guys, is we're going to multiply the coefficients. So we'll have 3 times 5 times x times y. Okay, so 3 times 5 should give us 15. So we should get 15xy, and that's our answer. Then the next one here, we have a half p times 8q. So we're going to multiply the half times the 8 and multiply the p times the q, and we're going to end up with 4pq. So that's the answer for these two. Then the next one here, we're going to multiply the coefficients first. 5 multiplied by -3 multiplied by y multiplied by y, which should give us -15y squared. Then this one here, guys. All right, guys, so the first thing we're going to do is multiply the coefficients. So we're going to have 4 times 3, which is 4 multiplied by 3. Then we're going to multiply the like terms, okay? So we're going to end up with p squared multiplied by p cubed multiplied by q cubed multiplied by q. Cool? And in this case, what we're going to actually do is we're going to write them all out in this case. 4 multiplied by 3 multiplied by p multiplied by p, which is p squared, and multiplied by p multiplied by p multiplied by p, which is p to the 3, multiplied by q multiplied by q multiplied by q, which is q to the 3, multiplied by q, right? So if we add all of these up, guys, we're going to get 4 times 3, which is 12. And we can see from the 1, 2, 3, 4, 5 p's, it's p to the 5. And the q is 1, 2, 3, 4, so it's q to the 4. Okay, guys? Let me just move this up here, and it would be q to the 4. Okay, guys? All right, now this one is pretty similar. First thing we want to do is multiply the coefficients. So this is actually a 1 for the coefficient here, but we're just going to ignore that 1. And we're going to have -2 multiplied by -3 multiplied by p squared multiplied by p multiplied by p squared multiplied by q multiplied by q multiplied by q squared. And we should actually end up with 6p to the 5 and q, there are 4 q's there, q to the 4. Okay, guys? All right, so that's pretty simple. And what we're going to do now, guys, is we're going to do some more examples. It's very important to practice these pretty often, okay? So we're going to do 4 more examples, and then we're going to move on to the distributive law. Okay, guys? So let's do the 4 examples. All right, guys, so let's look at these examples here. The first one, it says simplify the following. And the first one is x squared times x squared. So we actually should end up getting x times x times x times x, which should be equal to x to the 4th. Okay, guys? All right, and then in this one here, we have 6a divided by 2b. So we'll end up with 6a divided by 2b. 2 can go into 6 3 times, right? And we end up getting 3a over b, right? Pretty easy. These are pretty easy, guys. Algebra is easy, guys. Now let's move on and look at this example. We have 15x squared 15x squared y cubed and z divided by 3xy squared. So what we actually do in these cases, guys, when we have x as a denominator and x in the numerator, the first thing we want to do is divide the coefficients. So 3 goes into 15 5 times. We also want to divide the x's themselves. So in this case, x squared divided by x would actually give us x to the 1. Okay, so this x would remove that and give us x to the 1. And y squared over y, no, y cubed, sorry, over y squared would actually give us this y squared goes into y cubed and leaves y to the 1. So we're going to end up with y to the 1 here as well. And our answer is actually 5xyz. Okay, guys? Cool. So in this case, we're going to do the same thing. We have 18p cubed q to the 4 divided by a negative 3pq squared. So this negative 3 actually goes into this 18 6 times, and because it's a negative, we're going to end up with a negative 6 here. This p goes into this p3 once, and you're going to get p squared, and q squared goes into q4, leaving q squared. The 2 subtract the 4, leaving q squared. So we're going to end up with negative 6p squared q squared. Okay, guys, and that's the answer. All right, awesome. Okay, so we'll pretty much see how we can manipulate algebraic terms with multiplication and division. And now we can move on to the distributive law, right? We know how to multiply and put like terms together and divide and cancel like terms, and we should be okay going forward. All right, guys? So let's look at the distributive law. All right, guys. So now we're looking at the distributive law, and it says sometimes it is necessary to group terms together when they cannot be added or subtracted. We achieve this grouping through the distributive law by using brackets. Okay? As a matter of fact, we apply the distributive law both to insert or to remove brackets in algebraic expressions. Okay? And let me just give you an example of that, actually. That's a very, very good point. And we can see here that to remove the brackets, we have x becoming ax plus bx, right? But sometimes, guys, we actually do the opposite. There are times when we actually have ax plus bx, right? And what we actually do is we insert the brackets and we put x times a plus b, right? So we actually use it to insert and remove brackets in algebraic expressions. Okay, guys? All right, so let's look at these 4 examples here. Also, I forgot to mention that a and b are real numbers and x is the variable. Okay, so a would be numbers like 2 and 3, and x would remain x to the 1. Okay. All right, so let's look at this example. This one, if we use the distributive law and break it down, we're going to get 5x plus 5y. Pretty simple, right? Pretty easy, very easy. And yeah. And for b now, we're actually going to get 3 times 5x, which is 15x, and 3 times 2y, which is minus 6y. Cool, really easy. Same thing here, we're going to get negative 7a for this one, minus 7b. And for this answer, we're going to get, well, actually, I'm going to write it out first. Negative 8 times 3a would give me negative 24a. And negative 8 times 2b would give me plus 16b. But I'm going to write the positive one first. 16b plus a positive 16b minus 24a. Okay. All right, so it's pretty simple, guys. Really a walk in the park when it comes to the distributive law. All you have to do is multiply the term on the outside by the inside, Or you factor out the term that's common to both. X is common to both of these, and we'll put the x on the outside and put the brackets of whatever is on the inside. Okay. All right. So now we're gonna look at some more examples. All right. Let's look at some more examples and see how the distributive law pans out. All right, guys. So let's look at some examples of the distributive law now. Okay, guys. And the first one here says 3x plus y plus 5 times x plus y. Sorry. All right, so we're going to look at the examples here, and it says remove the brackets and simplify the following, okay, with the distributive law. So the first one is 3x plus y, so we're going to get 3x plus 3y plus 5 times x should give us 5x, and 5 times y should give us 5y. So if we group the like terms, we're actually going to end up with 5x plus 5x, which is 8x, and 3x plus 5y, which is 8y. So it's plus 8y. And that's the answer, guys. 8x plus 8y. Cool. So the next one here says 4 times 3x minus 2y. So let's just break that down. We're going to get 4 times 3, which would give us 12x, minus 2y, which would give us negative 8y. Then plus 3 times 4x, which would give us another 12x, minus 3 times 3y, which would give us negative 9y, right? Okay, guys, so when we break this down now, we're going to get 12x plus 12x, which give us 24x, minus 8y minus 9y, which should give us negative 17y. So that's the answer, guys. 24x minus 17y. Cool. Pretty simple, right? Just group the like terms and multiply through the brackets. So for this one now, we're going to get 7 times x, which is 7x, plus 7y, minus this negative 4 times 4x would give us minus 4x, and the negative 4 times y would give us a positive 4y. Cool. So it would actually end up with 7x minus 4x would give us 3x, and 7y plus 4y would give us plus 11y. So that's the answer. 3x plus 11y, right? Now for D here, we have 8 times 5, which would give us 40x, minus 2y, which would give us negative 16y. Then we have a negative 3 times 4x, which would give us negative 12x, minus 3 times minus 3 would give us a positive 9y, right? Okay, so when we group the like terms, 40 minus 12 would give us 28x, and negative 16 plus 9 would actually give us negative 7y. So the answer for this one is 28x. Oopsie, that's kind of too far away from it. Let's write x closer. 28x minus 7y. Cool. All right, so let's look at the last one here. We have a half multiplied by 2x, which would give us x. And then we have a half multiplied by negative 1, which would give us negative a half. Then we have negative a quarter multiplied by x, which would give us negative 1 over 4x. Then this negative a quarter times 1 would give us negative a quarter times a negative 1 would give us a positive 1 over 4. Cool. So we're going to group the like terms together. X minus 1 over 4x would give us 3 over 4x. Then negative a half plus 1 over 4 would actually give us minus 1 over 4. And that would be the answer. Okay, guys? Cool. So we can see that the distributive law thing is really not too hard, guys. And it's simple as day. And we can actually move on now to factorization. Okay? That's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.